All right, welcome to lesson 4 of the History of the Universe project that we are going to be working on here. Lesson 4 is all about nuclear fusion and the creation of new elements. And our essential question, our guiding question today is what makes a star shine? What are we made out of? How do we get here? Turns out the answer lies in the belly of stars. We're going to learn about how nuclear fusion has led to the creation of all the elements we find here on Earth. That's our goal today. What is it that makes stars shine? Have you ever thought about this? What is starlight? We know that it's electromagnetic radiation. There are photons coming out of the star, hitting us on the planet here, giving energy to our ecosystems. But what is it that makes a star shine? Well, we're going to look at that process right here. It turns out that what makes a star shine is something called nuclear fusion reactions. That's what makes a star shine. Nuclear means like the nucleus of an atom, and fusion means join. What's happening at the very center, at the core of stars, is nuclei are running into each other and they're joining up together. They're fusing together, and it turns out that process releases a lot of energy in the form of photons. We're going to look at that process in detail, but whenever these nuclei are fused together, they create heavier elements and they release energy. And this is what we see and feel here on Earth. It turns out this is a big periodic table of elements here. Let me get myself out of the way. This periodic table is made out of elements, and each one of these elements, with maybe the exception of hydrogen, helium, lithium, some of these light elements, all of these elements were born in stars. So me and you were made out of carbon, we're carbon-based life forms. We were made in stars. It's a really cool concept and something that I think is a sort of a poetic concept as well. Okay, what is in an atomic nucleus though? It depends on how small you want to go. The level that we need to know is that any atom is made out of 3 sort of elementary particles. One of which is called the proton. It's at the nucleus of an atom, and this is a positively charged particle that is at the nucleus. It has another particle called the neutron, which has no charge. It's neutral, thus the neutron. And they're both pretty similar in mass, and they compose the nucleus, the center of an atom. And they're held together by something called the strong force. The third part of our atom is going to be the electron. The electron, which is a stable subatomic particle with a negative charge of electricity. And these electrons will orbit around in electron clouds, they'll orbit around the atom. It turns out that if you were to remove the electrons and just stack up the nuclei, if you were to take my body, remove all the electrons and just stack up the nuclei of my body, I would only be the size of about a grain of rice. So really small. Turns out atoms are mainly filled up with just empty space, and I don't know, that's an interesting idea. But what it turns out is happening is that these nuclei are really important for our star to shine, and they're important because of this process right here. This is what is happening at the center of our star, happening at the center of any main sequence star that we know of, and it's something called the proton-proton cycle. And this is nuclear fusion. This is what it looks like in real diagrams. We start out with 2 red dots here, which represent protons. In this case, they might be essentially hydrogen atoms that have been stripped of their electrons. They smash into each other. One of the protons loses its positive charge in the form of this positron right here. And then it gives us 2 other things, one of which is a neutrino, which is a absolutely microscopic particle that's buzzing around, flying right through me and you. It's so small it doesn't interact with anything, and it's not super important for our equation. But the other thing that comes out of these 2 protons ramming into each other is a gamma ray, and a gamma ray is a super high energy ray of electromagnetic radiation, which ultimately is what is giving us light and heat here on Earth. This is the first step in the reaction. Two protons run into each other. We get a deuterium nucleus, which is a neutron and a proton, and then we also get energy, this gamma ray. What happens after that is we take our deuterium nucleus, collides with another proton to create this guy right here, which is something we call helium-3. And believe it or not, it gives us another gamma ray. Already we've got two really high energy rays of gamma radiation created in nuclear fusion. And it's these rays that get released in these two steps right here that are going to give us the energy that we see and feel coming from the sun. Last but not least, these two steps happen twice. So we get helium-3 twice. Helium-3, helium-3, they run into each other. They create a plain old helium nucleus, which we see right here, and then two protons, which, if you're keeping track, is what we started with, which is why we call this a cycle, because we can go through all these steps and we end up with two more protons that can continue the cycle. All right, that's what nuclear fusion is. It's protons fusing together and releasing gamma radiation. If someone just had to ask you why does the star shine, you could say it's hydrogen atoms fusing together, creating helium and releasing high amounts of gamma radiation. That would be a great answer if anyone ever asked you. Why aren't there any electrons in our diagram? Well, it's because at the temperature or the core of a star, it's actually plasma, and the electrons and the protons, they no longer have enough energy to stay bound together. The electrons go zooming off their own way, the protons go their own way, and we call that plasma. They're ionized particles. All right, what holds a star together? This is a quick think, something you can think about on your own. And if you think about the energy from nuclear fusion and these gamma rays getting released, tons and tons of energy, it's like an atom bomb going off the center of the star. What's holding the star together? Why is it not just flying apart and exploding all the time? It's actually very stable. It's not changing in size. So what is causing that? I'll give you a moment to ponder that. But it turns out what it is gravity. Gravity is acting against gamma radiation. All the mass of the star has a lot of gravity, and it is trying to essentially crush the star down, while the nuclear fusion reactions are trying to blow the star up. These two forces are constantly battling, and in a main sequence star, they've reached this equilibrium where it's actually very stable. It knows exactly how much energy is going out, and it's balanced by the gravity pulling it in, and it doesn't change size. That's what holds a star together. All right. These are the abundance of elements in the universe, and you'll see that this log scale here, hydrogen and helium, way more than anything else. And that's what stars are made of, mainly hydrogen and helium. All right, we're going to move on. This diagram here is the periodic table, but what it shows you is where different elements were formed. If it's this purple-blue color, it means it was around at the very beginning of the Big Bang. If it's a light blue color, it's from cosmic rays. If it's green, it came out of large, high-mass stars. If it's this orangish color, that means it came out of a supernova, and so on. And I think that this chart just demonstrates well. It reminds us that all the elements that we know of came from the Big Bang or out of a star. And with a few exclusions, the one at the bottom, the purple ones, are things that we made here on Earth that are very unstable. But for the most part, the elements we interact with every day are made from stardust. To elaborate on that point, we have this video from Carl Sagan, and you guys can watch that on your own time. So at the end here, what makes a star shine? It is a nuclear fusion process in which protons run into each other, they create helium and release huge amounts of electromagnetic radiation in the form of gamma rays. That's our summary for today. All right, that is the end of lesson 4. You guys can please go watch this video, and you can move on to the next lesson when you're